Happy Tuesday today. One might say Taco Tuesday, but I'm not having tacos today. Three things I want to accomplish today. We got some notes to go over, so we're going to do that. Got some notes to go over. We've got, I got tests and stuff to hand back. I want to get that done. And then, yeah. Oh, homework. Time to do homework. So, yeah. So let's get her done here. Just a reminder, you will have a quiz this week, Friday. Okay, so quiz this Friday. All right. On page 11 in your note packet, I just want you to do 1 and 2 in the retrieval. Okay, because I don't think 3 is. Oh no, yeah. I just want you to do those 2 in the retrieval, and then we'll do the jump start together. Okay, all right. So just doing, finding me parallel slopes, perpendicular slopes, finding me those 2 points, and then find me a slope of the line segment, distance between the 2 points, all that good stuff. Go for it. Of my original line here in number 1, what is the slope of that line? 2/3. Okay. So what would my parallel slope be then? 2/3. What would my perpendicular slope be then? -3/2. Love it. Of my second one, of this original line, what is the slope? Ooh, I've gotten 3 different answers so far. Okay, so how do we figure out the slope of it? So solve for y. Okay, so my first thing I'm going to do is I'm going to subtract 3x. Then I'm going to divide by -4. So that's going to give me y equals +3/4 x minus 3/2. So what's the slope of that line? 3/4. So what's my parallel slope? 3/4. What's my perpendicular slope? -4/3. Love it. Good job. Okay. Use the 2 points -2, 3. That would be right here. That's point -2, 3, and the point 4, 5. Be right there. Okay. So we are going to plot those points on the grid. Boom, done. Second thing, we're going to find the slope between those two. Well, what is this? How much did we rise? 2. How much did we run? 6. So what's the slope then? 1/3. Is it run over rise, or is it rise over run? Or is it run? So you want to change yours to what? Nope. 1/3. Okay. Then it said use the Pythagorean theorem. So now we want to find the length of this purple segment. Okay. Well, Pythagorean theorem would say 2 squared plus 6 squared is equal to c squared. 2 squared is 4. 6 squared is 36. 4 plus 36 is 40. So c squared is 40. So then what do I do to get c? Square root both sides. Can I simplify the square root of 40? What? Can I simplify it? What does it simplify to be? 2 squared is 10. Okay. Because the square root of 40 is the square root of 4 times the square root of 10, which is 2 square roots of 10. Good, good, and good. All right, so let's jump started, okay? So we're given point A is located at 2 comma 6. That is on our paper at 2 comma 6. Its image point, A prime, is located at 6 comma 2, as shown in the diagram. Describe the following transformation. So what would a translation that would map point A onto point A prime? What would a translation be? Lily, give me one. Right 4 and down 4? Yeah. Okay. So how could I write that? Yep, exactly. X plus 4, that would be my right 4. Oops, I put a parentheses there that shouldn't have been. X plus 4 is my right 4. Y minus 4 is my down 4. Exactly. A reflection. Now, what do we reflect in? We've only reflected in one thing so far. What do we reflect in? A lot of people must have done their homework. What? A line. Yeah, exactly. So we got to come up with a reflection line. Okay? So this is kind of goes to last night's homework. What's the first thing that we got to do? The slope between A and A prime, right? Okay. What is the slope here between A and A prime? So far I've heard 3 numbers. What's the slope between A and A prime? -1? Okay, all right. So my original slope is -1. So the line of reflection has to be perpendicular to that, right? So what would that slope be? It's perpendicular to -1. So that would just be 1. Yep, exactly. Yep. Because it'd be -1 over 1. The opposite makes it positive. The flip makes it still 1 over 1, which is just +1. Okay, so that's the slope of that line. Second thing we got to do now is we got to find the midway point, the halfway to that point. So I went 1, 2, 3, 4. I went across 4 squares, which means halfway I would go across. If I went total of 4 squares, halfway I would go across just 2 squares. So I have to go through that point with a slope of +1. Missed it a little bit. What is the equation in that of that green line? Yep. So we would say that that transformation would be reflecting over y equals x. Is there a rotation that we could do? Yeah. Yep. Okay. What do we need for the rotation? We need three things for a rotation. We need a point that we're rotating around, a direction and a degree. Okay? So before we set the point, give me the direction and give me the degree. Clockwise 180. Could we go counterclockwise 180 too? Yeah. Either one? Yep. Okay. All right.
Would it be 180? Would it? No.
Yep. Yep.
Oh, yeah.
And now we got to pick our point. The middle point, yeah. Because then it's going to be on that blue dashed line. Yeah. So that would be the point 4, 4. So we can either say rotate it clockwise 180 degrees about, or you could say around there. Okay, either one, about or around the point 4, 4. So you have to have three parts for a rotation: direction, angle, and what point you're rotating it around. Okay? Love it. I'll just give you a quick brief example of two of them that would do that. So we could say we could reflect in, let's go y equals 3. If I reflect that point in y equals 3, here's the line y equals 3. Nope, I lied. Y equals 4. My counting was off. There's the line y equals 4, so if I reflect it, then that's going to move it to right there. That's my first one. Okay? Then I could reflect it in x equals 4. And that would put it to A prime. Okay? So that would be an example of one. Okay? I could have said, instead of reflecting it in y equals 4, I could have said translate it down 4. And then reflect it in the line x equals 4. Okay? Combination of any of those would work. Okay? Love it. Let's talk frogs. Okay. So Josh is animating a scene in which a troop of frogs is auditioning for the Animal Channel reality show, The Bayou's Got Talent. In this scene, the frogs are demonstrating their leapfrog acrobatics act. Josh has completed a few key images in the segment and now needs to describe the transformation that connects the various images in the scene. For each pre-image image combination listed below, describe the transformation that moves. So all we're talking about is what transformation moved it from one to the next. Okay? All right. So let's start with image 1. Image 1 to image 2. What transformation took place? Translation? Okay. Can you give me some specifics? Come up with the specifics for the translation. Wait, Brie. Right 6 up 7. Okay? So I'm gonna go off of what's closest. I'm gonna go off of the what that would be is right leg, middle finger. Finger. You know what I mean? Because that's on a point. Okay? Alright? So then here that's that one. So then here would be my so you said right 7, is that what you said? Right 6. 1, 2, 3, 4, 5, 6. I would agree with that. And then you said up 7. 1, 2, 3, 4, 5, 6, 7. I would agree with right 6, up 7. Can we give it to us in XY form? Okay. Love it. So we're at image number 2 now. Image 2 to image 3. You're tracing paper to see if it's a rotation? Yeah, by all means. Almost has to be a rotation, right? Right? Well, let's think about it. What's the process of elimination? Is it a translation? Did it keep the same orientation as image 1 to image 2 did? No, so that one's gone. Okay? Reflection. Is it a flip? Remember, it's like flipping a pancake. A reflection's like flipping a pancake over a line, right? Is it a reflection? No, so that means it is a rotation. Okay, because that's the only 3 that we have. Now, it appears to me that I don't want to use green. I'm going to kind of box in here now. Right? So that box got rotated past to there, right? Okay. So in your brain, this is where it's a little tricky. In your brain, if it rotates 90 degrees, the frog would be laying on its side, correct? So how far did it go? When it went 180 degrees. Okay. So does it matter which direction we go? No, because it's 180 degrees. Okay. Now we just got to figure out that point, right? What do we got for dimensions here? 1, 2, 3, 4, 5, 6, 7. So this is 7 that way. 6 that way. Okay. So that means we should probably find the middle of there, right? I'm thinking right there is the middle. With me? Because the distance between the 2 boxes is 4, and we're already, so we can cut that in half. That's 2. And then if we go from the top of the left box, or the bottom of the left box to the top of the right box, that's a distance of 8, so we cut that in half as 4. That would be our rotation point, right? So what would that point be? 15, comma 27? Sweet. Okay. Image 3 to image 4. Did it reflect? I don't think it reflected. Did it translate? No. So that means it did what? It means it rotated. Okay. Do you see, Anna, how it didn't flip? Okay. So we're on another rotation. Talk to me, Rick. Okay. What's the thing that we're going to rotate around?
The top right.
So let's draw our box in again, right? Top right, middle toe. Let's draw our box around it again. So we went here.
Oh wait, no.
2, 3, 4, 5, 6. Yep.
Never mind. I thought you had some.
So let's find a point that would kind of goes. So this point right here, right?
I think it's gotta be in that. Are you like actually stuck or are you just like,
I'm fake stuck, just so.
oh.
So let's figure it out. What do you mean?
I think it's gotta be something.
It is on an actual point. It's on a whole point. So it is an actual rotation, and it is an actual rotation clockwise of 90 degrees. We just have to find the point.
What if it's like way out?
Okay.
Hold on. Wait. It's over here.
23, 23. This point right here. Okay, the problem with that is if I rotate this one 90 degrees, then that's going to end up right there. Okay, with me? So it can't be there. Okay, so let's move that over a little bit. Right?
I got it.
What do you got?
Wait, hold on. Oh, shoot. It's like, wait, yeah, I think I got it. Oh, wait, let's see. Wait, is it? Oh, I got 22, 25, but
What about Hannah's? 23.
oh, so that's way off. Let's go.
I got it right there. Because so if I'm going off of that corner right there, that corner goes to this corner, right? Okay? So if I go halfway, 1, 2, 3, 4, 5, 6, okay? The problem is that this space isn't equal all the way around, okay? So if I go here, so let me put it in black so you can see it. So that needs to rotate 90 degrees clockwise, so then that would be 4 here and right there. Is there only one what? There can only be one rotation point. Yep. Okay. 4 to 5. Okay. Bless you. Try it. Try it and figure it out. See if you can. It is a rotation. It is clockwise. See if you can figure it out. You'd have to. So we could rotate it. So we could literally. You could do a couple of different things here. You could rotate it. Okay. So we could rotate it 90 degrees on that point right there. Clockwise. What point is that? 30, 16. Okay? So now my image is sitting like this. Okay? Then we can translate it down. I would need to, so we rotate it over here, so now that's going to be, so I would go back to 3, x minus 3. Nope, I lied, I want to go out to here. I want to go to here. That's where I want to end up. So that would be x plus 4. And then y minus 12. Okay? So first we rotate it. So now the frog is sitting up here, but he's looking out towards the wall, right? Then we drop it down here. So now they're right next to one another. And then, at last, we do what? We reflect it in what line? Yep. X equals what? Is it 35? I thought it would be 34. 34. Okay. Now, give me 2 transformations for image 1 to image 5.
Oh, I got this. Not yet, but I know.
So just going right from image 1 to image 5 in 2 transformations. That means you got to come up with 2 different things to do. First transformation. What do you want to do first? Down 12.
So why not?
Just straight down 12. And that's it?
Yeah, I think first sometimes we move it. Well, I think.
Okay. So it's straight down 12. Okay. Give it to me. What you got next? So if I go down 12, that puts me here. And then I'm 7 up, right? So that's 23. So that's 11. And then you said reflectance x equals 20?
Yep.
No. Because that would be this line right here. See how much bigger this gap is than this gap? You understand what I'm saying?
Yeah.
Because that gap would have to be halfway, right?
Mhm.
16 would be here.
17.
So this gap would be 3, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it has to be 17. Yep, so it'd have to be 17. Yep. Okay. Could have we translated it all the way over to here and then flipped it around that one? Yeah. Could have we translated it down to here and then flipped it? So there is no one right answer to any of these. Okay? Alright? Take a quick peek at your homework tonight. So we're graphing some ordered pairs, finding the slope between the pair, and then using the Pythagorean theorem. So there's graphs there for 1 and 2. Okay. For number 3, the back side of your yellow toolkit might be very beneficial for you. Hint, hint. For number 4, we're just doing those different transformations. 5, 6, and 7, doing all those different transformations. 8, 9, and 10 is all about if it's arithmetic, geometric, or neither. That's first semester learning, cyclical stuff. And number 11, domains and ranges, maximum and minimums, finding values of the functions at that. So yes, love it. Okay. This one here, g of x should equal, in number 11, g of x should equal 2. Okay? It should be equal to 2. There, not minus 2. Make that change right now because otherwise the problem doesn't make much sense. And then in number 12, you're just doing order of operations. Please excuse my dear Aunt Sal. Okay. Is there more down here? And then, and then doing kind of like what we were doing in the frogs. 1 to 2, 2 to 3, 3 to 4, 4 to 5. Okay? Good stuff.